Hello there, and then welcome to a brand new lesson. This is How Beyond Numbers, where we learn maths the easy way. In this lesson, we are looking at the sum of interior angle of a polygon. The sum of interior angles of a polygon. Without much ado, let's quickly go into it. Now, in our previous lesson, we looked at what a polygon is. We said a polygon is a closed figure formed by what? Three or more line segments. Three or more line segments. So it is a closed figure. Okay. And I also introduce you to what the interior angles are. So as you can see on your screen, I've drawn some polygons. The interior angle of this polygon, which is a three-sided figure, and then a three-sided polygon is a triangle. So these are the interior angles. That is the angles inside. You see? Then if you take this rectangle here, these are its angles as well. You see? So the angles inside are what we call the interior angles. Okay. Now, if you look at what I've done carefully, you realize that the number of interior angles corresponds to the number of sides of the polygon. So that if you take the triangle, we have 1, 2, 3 angles. And it also has 1, 2, 3 lines. You see, if you take the quadrilateral or a rectangle, it has 1, 2, 3, 4 angles. And it also has 1, 2, 3, 4 sides as well. Okay, so how do we calculate the sum of all the interior angles in the polygon? First of all, we have proved that the sum of interior angles of a triangle is 180. You see, so just with one triangle, we would depend or base on one triangle to get the rest. What do I mean by that? For each of the triangles, for each of the polygons here, I'm going to look at how many triangles I can draw out of them. Okay, so for this quadrilateral, I can draw two triangles. 1, 2. Now for this five-sided figure, I can draw, this is one triangle, this is 2, and then this becomes 3. You see. Then for this six-sided figure, I can also draw, so we have 1, 2, and then 3. 3 lines, making 1, 2, 3, 4 triangles. So with these triangles, we know first of all that the sum of interior angles of a triangle is 180. So if it is 180 and we have two of the triangles here, then the sum of interior angles, so if we add this angle to this angle, to this one, to this, and also to this, we have two triangles, which will then give us what? 2 times the 180. You see? Now, how many triangles do you have here? 1, 2, 3, 4. So we have 4 triangles, and we know one triangle is 180. So 180. Now, how many do we have here? So 1, 2, 3. You see? So we have 3 times 180. So simply put, if you want to get the sum of interior angles, then multiply 180 by the number of triangles you can find in the polygon. But this is going to be a long process, especially if you have very, very big or polygons with larger number of sides. Hence, what do we observe? If you look at this polygon, it has 4 sides. And 4 minus 2 simply gives us this 2 over here. You see? So if I take the number of sides and I subtract 2, I'll get to this 2. if you look at this polygon, it also has 6 sides. And you realize that 6 minus 2 gives me this 4 over here. Finally, if you look at this polygon, it has 5 sides. And I have 5 minus 2, which also gives me this over here. Hence, we can conclude that if we want the sum of interior angles of a polygon, then it is best we use the formula n minus 2 times 180. N minus 2 times 180. And what do we mean by the n? The n simply has to do with the number of sides of the polygon. Now, this formula here would then mean that irrespective of the number of sides a polygon have or has, we don't have to draw it to inspect the number of triangles, because simply put, this n minus 2 would have given us the number of triangles, and we just multiply by 180. So with this formula, let's look at how we can apply in solving some questions. So starting with the basic ones, it says, what is the sum of interior angles of a quadrilateral? Of a what? Of a quadrilateral. Now, how do we go about it? First of all, we know that the sum of interior angles, S, is equal to what? N minus 2, then times 100 and what? 80. And your n is the number of sides. So from the question, a quadrilateral is a 4-sided figure, as you see over here. So our n is 4. So this simply implies that our S, which is the sum of interior angles, is going to be 4 minus 2. That is, we are substituting n to be what? 4. So 4 minus 2 times our 180. 4 minus 2 gives us a 2. So we have 2 times 180. You see, now our sum of interior angles is going to be 2 times 180, which gives us a 360 degrees. So what it simply means is that if you add all the interior angles of any quadrilateral, either it being a square, a rectangle, a parallelogram, a rhombus, a trapezium, a kite, what have you, so far as it has a 4-side, or so far as it is a 4-sided figure, they all sum up to what? 360. As simple as that. Let's look at another example. This next question here says, what is the sum of interior angles of a nonagon? Of a nonagon. And a nonagon has 9-sided, it's a 9-sided polygon. Okay, so following this same step, which you can pause and even try on your own, we know first of all that the sum of interior angles is our n minus 2, then times our 180. So with that, you just do your necessary substitution. Hence, we have sum of interior angles being 9. Since our n was given us as what? 9. So n equals 9 from a nonagon, which is a 9-sided polygon. So we have 9 minus 2, then times your 180. So 9 minus 2 gives us what? A 7. So we have 7 times 180 being the sum of the interior angles. 7 times 180 gives us 1260 degrees. So if you take any nonagon, the sum of its interior angles gives you 1260. Just as you can find the sum of interior angles, you can also find the number of sides, provided you have the sum of interior angles already given to you. Let's look at one question that applies that rule. So for such an example, we have a polygon has an interior angle sum of 1620. How many sides does it have? You see, so from this one, you realize that we have not been given the sides. That is what we need. Meanwhile, we have been given the sum of interior angles to be 1620. Now, how many sides does it have? What equation relates the sum to the number? So we know the sum of interior angles relates to what? N minus 2, then times your 180. So it's all about making our n the subject. So let's do our necessary substitution. S, which is the sum of interior angles, give us 1620 degrees. We are saying it's equal to n minus 2, then times your 180. This is where you apply a little algebra, specifically change of subject. So all we need to do is what? We just divide both sides by 180. You see, so I'm going to divide all this by 180 and also divide all this by 180 degrees. Then we can see our 180 cancels out our 180. And for this side, we choose to what? Simplify. So first of all, I can just cancel out my zeros. And then we say 18 divides 162 9 times. See, so what that means is all we have here will give us 9. So 9 is equal to, remember we have cancelled the 180s. So n minus 2. We still have to make n the subject. So making n the subject, we have n. So we have 9. Then the negative 2 moves to the other side as positive 2. So plus 2 is equal to your n. Simplifying further, it simply means that our n is then equal to 9 plus 2, which is 11. So our what? Polygon is actually 11-sided figure. It has 11 sides. And what is a polygon with 11 sides? What is its name? You can let me know at the comment section. Basically, this is all we need to know under the sum of interior angles. In our subsequent lesson, we'll also look at the value of each interior angles, the exterior angles, and then the sum of what? Exterior angles. As usual, I'll leave you with some exercise so you try to test your understanding. So here are just 3 questions you can try on your own. And I do hope that if you really understood the lessons, you'll be able to do them. Let's have Beyond Numbers, where we learn maths the easy way. If there's any issue of concern, you can always let me know at the comment section. If this is your first time on this channel and you think it would be of help to you, you can choose to subscribe if you so do wish, so that anytime I release a video, you'll be notified as well. See you in our next lesson, and bye for now. Stay blessed.